negative 1 cubed plus 10 times negative 1 minus 4. And so what it does is it gives us that function value. So I now know that negative 1 is in fact a root because it gave me 0. So just for grins, I'm going to show you what happens if we don't. I can press second, enter, and notice that comes back up. And we can test, let's try negative 1/3. Okay, so negative 1 divided by 3. And I do that, and look, I get negative 6.88888889. So negative 1/3 is not a root. However, since I already found x minus 1, I'm going to go ahead and use that as my root, and I'm going to use synthetic division so I can determine the next root. Alright, so we knew that p of negative 1 equaled 0 from our calculator. So x plus 1 is a root. So I went ahead and drew out the synthetic division. We have 3, negative 11. We have a 0 because we had no x squared term, positive 10, and negative 4. So I bring down the 3. That's a positive 3. So negative 1 times 3 is negative 3. That's negative 14. 3 times negative 14 is 42. Or, that's not 42. That is negative 14. Which, that gives me another. That's positive 14. Oh my goodness. Negative 1 times negative 14 is positive 14. So that gives me 14 right there. The negative 1 times 14 is negative 14, which gives me negative 4. Negative 1 times negative 4 is positive 4, which is 0. So I now know that p of x equals x plus 1 times 3x cubed minus 14x squared plus 14x minus 4. Okay, so from there, if you notice, I can't factor that, so I have to either do synthetic division, or we can go back and do the trusty calculator dealy-majig thing. Sweet! Alright, so, again, I'm going to press second, enter, and it comes back up. Remember, I know that negative 1 didn't work, negative 1/3, or negative 1 did work, so we can go ahead and check that baby off. We cross out in negative 1/3 because it did not work. And then I'm going to go back here and we're going to try positive 1. So I'm going to deleteify the negative. I guess I could hit delete for all of it and then just type in 1, close the parentheses. Oh, we get negative 2. It's not 0. So I mark off 1, then I try 1/3. Second, enter again. 1 divided by 3 does not work. So my next number is negative 2. Notice I've crossed out all of those. So we come back over here, second enter, do some deleteifying, type in the negative 2, and we get 112, which doesn't help because it doesn't work. My next number is negative 2/3. So I do second enter, divided by divided by 3, so it's negative 2/3, and negative 2/3 doesn't work. Man, isn't this so much nicer using the calculator than having to do that whole synthetic division for all of that? Why, yes it is, Mr. Otto. Oh, I'm so glad you agree. Okay, so let's try 2 now. Second enter, and we're going to do positive 2. And it's negative 24. Well, so we mark that one out. Alright, so our next one is positive 2/3. So I do second enter, I do divided by 3, and oh my goodness, it worked. So we know that 2/3 is a root and negative 1 is a root. maybe those other ones are roots, but I've got one. I'm going to go do some... I'm going to use this right here and do synthetic division with this part, because if I do synthetic division with the original, the 3, negative 11, 0, 10, and negative 4, I'm going to end up with another thing that I still have to do synthetic division with. So, 2/3. Oh my god, it's a fraction! Life's over, I hate fractions! Okay, stop complaining, it's okay. We're going to do 3, negative 14, positive 14, and negative 4. And then we do all that, drop my line down. So now, bring down the 3. 3 times 2/3 is, oh, 3's cancel. That's a 2. That's nice. Negative 14 plus 2 is negative 12. Oh, 3 goes into negative 12 negative 4 times. So 2/3 times negative 12 is actually negative 8. Then 14 minus 8 is 6. 3 goes into 6 2 times. And then 2 times 2 is 4. So 2/3 times 6 is 4, and that gives me a 0. Phantasmagoric. So then, I know that P of x is going to equal x plus 1 x minus 2/3 and 3x squared plus, or, minus 12x plus 6. Okay. Alright, so at this point I want to look at 3x squared minus 12x plus 6. Well, if I look at 3x squared minus 12x plus 6, and I'm going to set it equal to 0, because I'm going to try to solve that either by factoring or using the quadratic formula. So what do I notice? Well, first off, they're all divisible by 3. Well, that's going to make my life easier. Minus 4x plus 3. Is that really right? 3 goes into that. Nope, that should be a 2. Too bad it's not 3. If it was, it would have been factorable. Okay, so we look right here. X minus 4x plus 2 equals 0. That is not factorable. I got that by dividing each one of those by 3. So I'm going to use the quadratic formula. X equals negative b, so that's 4 plus or minus the square root of 16 minus b squared minus 4 times 1 times 2, so 4ac. Okay, well this is really just 16 minus 8, because 4 times, oh wait, I forgot, all over 2a. So that's just 2 times 1 is 2. Okay, so that's 4 plus or minus the square root of 8 all over 2. Okay, so then I'm going to take 4 plus or minus square root of 8 is really 2 root 2. Divide all of that by 2, and then we get that x equals 2 plus or minus root 2. Because if I divide 2 into both of those, they get reduced. So then I know that my roots are x equals negative 1, positive 2/3, and 2 plus or minus root 2. Notice there are 4 roots. 1, 2, 2 plus root 2, and 2 minus root 2. Alright, so we have P of x equals x cubed plus 6x squared plus x plus 6. So at first glance, I see x cubed plus 6x plus x plus 6. It's factorable. The book provides it as an example. And I'm going to go ahead and use this method, but let's first, well, we notice that it's factorable, but there's some really interesting things that happen if we end up with one like this that is not easily factorable. Okay, so if I factored that, that would be x squared times x plus 6 plus 1 times x plus 6. So I'd have x plus 6 times x squared plus 1. So I'm going to use, and that's just some information that you really don't care about. So moving on. Let's do, I know that a sub n is equal to 6, and a sub 0 is equal to, a sub n is equal to 1, and a sub 0 is equal to 6. Okay, so then I'm going to do c. Remember, c is always this last term, so that's positive 6. D is always this first term, and that's 1. So the only factors of 6 are 1, negative 1, 2, negative 2, 3, negative 3, and 6, negative 6. My factors of 1 are 1 and negative 1. So what's really nice is c over d are basically just going to be these factors right here. 1, negative 1, 2, negative 2, 3, negative 3, and 6, negative 6. Now, if you notice, this polynomial is positive. If I took any of these positive values and plugged them in for x, that would only get more positive. So, if every single term here is positive, that means you can mark out all the positive values, like so. Okay, so the only values worth testing are negative 6, negative 3, negative 2, and negative 1. Because those are the only ones that are going to work. Well, like I said earlier, this is factorable. Since it is factorable, I know how to factor it. I know that negative 6 is going to be one of the answers. So I'm going to do negative 6. I do 1, 6, 1, 6. I bring down the 1. 1 times negative 6 is negative 6, so that's 0. Well, negative 6 times 0 is 0, so that's 1. That gives me negative 6, which is 0. Okay? So then I look, oh, well, that's p of x equals x plus 6 times x squared minus 1. Which, had I factored it, I would have gotten that. Okay, so then, oh, actually, that's x squared plus 1. So then x squared plus 1 equals 0. I just solve, I get x squared equals negative 1. So x is going to be plus or minus I. Because when I take the square root of both of those, the square root of negative 1 is I. But it's going to be plus or minus. Okay, so my roots are x equals negative 6 and plus or minus I. Now, looking at this right here, remember that if this lead coefficient is 1, like we had here, then all of the factors of that constant, the last term, are going to be that c over d. Because if we notice, 1 over 1 is 1. Negative 1 over negative 1 is negative 1. 2 over 1 is 2. Negative 2 over 1 is negative 2, and so on and so forth. So, that's one of the other key things. If everything is positive, you can mark out the positives. If the lead coefficient is 1, then all you need to do is look at that last term. Okay? So, that is the lesson. Now, your homework. Well, actually, I'll tell you that at the beginning of class.